So for matter, we already solved this. W is equal to 0, and then we found the geometrical dilution with the expansion. Now let's apply that to radiation. For that, we'll look again at the equation of state. The pressure is equal to W times the internal energy. And we already worked out for photons from radiative transfer, the radiation pressure was equal to a third of the internal energy. That means that W for radiation is equal to a third. That's the equation of state for radiation. So applying this equation for radiation, you find that the density of radiation falls with the fourth power of the scale factor. Rad node here is the present density of radiation. So matter falls with the cube of the scale factor, but radiation falls with the fourth power. We understood the evolution of matter going as a cube of the scale factor as a geometrical dilution factor. Now, this equation here implies that photons experience another factor A decrease in their density aside from the A cube factor from geometrical dilution. This is understood as we realize that according to matter energy equivalency, this can also be read as that the internal energy of radiation is also falling with the fourth power of the scale factor. Now, a factor A cube indeed is from the geometrical dilution from the expansion. The extra factor A comes from long wavelength photons being red-shifted with the expansion. As radiation is traveling through an expanding universe, the photons are being red-shifted. And as a photon is redshift because of the dependency of energy and frequency, a photon being redshifted is losing energy. And that is the linear factor that was missing. So the evolution of energy is, this cube here is geometrical dilution, and this linear factor is the redshift. Altogether, then they give you the factor 4. So here you have the behavior, the fall with A to the cube, that's the red one for matter, and the fall with A to the 4, that's the green one here for radiation. The present density of radiation is very, very small, much, much less than the density of matter. But notice that as you dial back the clock and the scale factor becomes smaller and smaller, eventually radiation would take over and become the dominant force driving the evolution of the universe because of this fall of A to the 4 instead of A to the 3. If you write that in terms of redshift, you see that the influence of radiation increases with redshift. Even though now matter is more dominant than radiation, that has not always been true. And in fact, for the early universe, is radiation that dominates. So let's see how the effect of radiation impacts the early universe. Our previous estimate then of early universe that is matter dominated is wrong. We should redo the analysis for a radiation dominated early universe.